Okay, so today we're talking about pulleys, how they work and how we use them. So fundamentally, pulleys bend force in one direction or another. So here I have a barrel with about 9 or 10 kilos of water in it. So to counteract gravity, I have to pull up with that much force. Okay, the rope comes up here and goes through a pulley. So now if I pull on this side, all the pulley's doing is bending that force back down the other way. So now I'm pulling down rather than pulling up. So it's a bit easier. I can use my own weight to counteract the mass that's hanging there. One thing to note, however, is that up here, what's happening is that the tension I'm putting in there comes through here and goes down there. So you've got a tension in each of these lines. Those two lines add together, and up here at the head of the pulley you've got two tensions. Okay, so if that weighs 10 kilos and I'm pulling down that way with 10 kilos, up here you've got a load on the anchor of 20 kilos. So this is an example of why it's really important, if you're belaying from the bottom on a top rope, either in a climbing wall or outdoors, you've got to be absolutely sure of how good your belay is. It's got to be really good belay, because if your climbing partner weighs 100 kilos and you weigh 100 kilos and you're belaying him like that, up here there is 200 kilos of load on that anchor. So you've got to have really good anchor when you're bottom belaying. So back to pulleys. So all this pulley is doing, as we said, is bending the force around. It's not making things any easier for me, other than the fact that I can hold on and use my own weight to pull backwards. If I get another pulley and flip it in to something that will grab the rope, in this case a Prusik lute. If you're working with another team, it could be a petrol rescue sender or a jammer or something like that. So now, if I put a tension in this line here, one tension in the rope goes around the pulley, one tension in this rope. But as we saw before, those two tensions add up and you get two tensions in this carabiner and in this loop. So this one tension carries on going, goes through there, comes back down there. One tension, two tensions up the top. So that one tension comes down this line until it gets to here, at which point it adds on to the two tensions coming down this side from this carabiner, and suddenly I've got 3 times the tension down here that I'm putting in up here. Bargain. No such thing as a free lunch, of course. Energy is force times distance, so to move that up by 1 meter, I have to pull 3 meters of rope through here, so it's only moved up half a meter, and I've had to pull all of that rope up. So yes. Right. Now the problem with this is if I let go, it falls. So really what we need is some way of catching the load, and we can do that if I move that down to another Prusik down there. If I take this Prusik and put it in there and tighten it up so it's snug. Now when I pull up, if I let go, the Prusik catches it. Brilliant. The problem with that is that it's quite hard to lower something back down again. With only 10 kilos of water in a barrel, I can hold it with one hand and hold the Prusik so that it moves down. If I was trying to do this with 200 kilos of casualty, rescuer and stretcher, I would probably need a lot of people, or I would give myself rope burns. So we're going to replace this pulley with a device known as a progress capture device. Now there's lots of these on the market. If you're working for a different team or with a different team, you might see something like this. This is a Petzl ID. You might see a Petzl rig or an ISC D4. They all do roughly the same thing. They allow the rope to run over one way and then catch it when it goes back the other way. But also, as well as catching it, they give you the chance to do a controlled lower. So we can raise through them, we can also use them to lower the same system, the same rope. So that's my Edel Quadra in there. So now, same as before, if I pull up here, if I pull up here, 10 kilos of force. If I pull down here, it's theoretically 10 kilos of force, but because this isn't actually a pulley and the rope is actually sliding over a metal capstan, there's a lot of friction in there. So actually I have to put in a bit more than 10 kilos of force to pull it down. But as we said, we can do a controlled lower. So if we still got the same 3-to-1 system in place, so now I can pull up with one hand quite easily, and if I let go, it catches. Brilliant. How's about I get another pulley and put that up here. Now what we're looking at here is a compound pulley system. Now right now, all that pulley is doing is diverting the force of me pulling up, so I don't have to pull up, now I can pull down. Hasn't made it any easier for me. What I could do is put another 3-to-1 here. Okay, so I've now got a 3-to-1, and that 3-to-1 acts on the end of this 3-to-1. So now I have a compound pulley system which is a 9-to-1. Okay. Another thing we can do is get another pulley, clip that in down here. Now when I pull up, this pulley is connected to the load and it is making things a bit easier for me. So whereas before we pulled on that and we saw that there's 2 tensions in that carabiner there, 1 tension in that carabiner, so it's a 3-to-1. Now I'm pulling on this rope, going through a pulley, so there's 2 tensions acting on that carabiner. Still 1 tension in the rope, goes around the pulley, 2 tensions in that carabiner, still 1 tension in the rope, goes around that pulley, 1 tension in the end. So now I've got 1, 2, 3, 4, 5. So this is a 5-to-1. So now I'm pulling up with approximately a fifth of the load that is hanging there. So we can construct some pulley systems that put a lot of load down here, okay? If we cancel all this out, if we had a single rope going up over the edge and 20 people pulling on that rope, okay, that would move whatever is on the end of that rope up. However, if that stretcher got caught on something, those 20 people will start pulling. Now the stretcher's caught on something, and potentially you start straining things to a point where they don't like being strained anymore. That's with 20 people pulling. So what we like to do is reduce it down to a total of 12-person pulling power. Now obviously everyone's grip strength and ability to pull is going to be different, but on average 12-person pulling power is enough so that if the stretcher gets caught, you're probably not going to overload anything while you're pulling it. So here we have a 3-to-1, 12-person pulling power, so you should only have 4 people pulling on a 3-to-1, okay? This is a 5-to-1. So if we have 3 people pulling on a 5-to-1, the force multiplies and you end up with about 15-person pulling power, which is a bit much, but it's not a disaster. If you knock it down to 2 people pulling, then it's 10 people pulling power, which is absolutely fine within limits. And you might find that, yeah, if you're short-staffed and you need to raise that stretcher up, that load up, if you're short-staffed, then put in a 5-to-1 and you can get away with just 2 people pulling, because that's really easy. I'm supporting that 10 kilo weight with just my 2 fingers. And that's about it. So pulleys bend force around. If you create a system where those forces add up there and then attach to another line that's attached to the load, we can increase mechanical advantage. So I can pull up 3 times as hard as I'm just pulling, or on this one I can pull up 5 times as much as I'm just pulling. But I have to pull 5 times as far, or 3 times as far from just pulling that. So yeah, that's it. So do you need to know this? Yes, it's a good idea if you know the 5 to 1, because if you're a bit short-staffed, it's really easy to do. You definitely need to know how to do a 3 to 1. Okay, this is absolute standard in all the rope rescue systems we use in EDAL. You will have a quadra, you will have a pulley and a prusik. Okay, and with that 3 to 1, you can effectively move a casualty up and as it happens, down. So reset, pull up, pull up, pull up. Oh, reset again, pull up, pull up, pull up. Okay, so that's what you will hear. You'll hear stop to reset or reset. Cool. Pulleys. This time with the camera running. So, pulley mechanics take 2 because I forgot to turn the camera on last time.